Hello, hello, hello out there. Let's talk about some variation today. Two kind of intro problems I want to look at first. So, first, think of the relationship between the number of people helping to build a house and the number of hours it takes. So, let's just assume people all work 8 hours per day and they're all had the same skills. None of that matters. So, we're just looking at number of people, number of hours it takes to build a house. So if the number of people increase, what's going to happen to the amount of time it takes to finish? Well, that's going to decrease. That should make sense. Well, what happens to if the number of people decrease, what will happen to the amount of time it takes to build a house? Well, that increases, that goes up. So just kind of think about that idea. And then if the job deadline got pushed up, what can you do to make sure you get the job done in time? Well, if you increase the number of people, that'll allow you to get it done faster. So just kind of a basic idea there, how as one thing was going up, the other thing was going down. Look at this next problem. Suppose you and some friends are buying a timeshare. The cost for each person per week is $2,000 divided by the number of people. So if the length of time is doubled, what happens to the cost per person? That doubles too. Well, what if the number of people triples? What happens? It'll be reduced to 1/3 of the original amount. What if the length of time and the number of people are both doubled? What happens to the cost for each person? It ends up staying the same because the way that was kind of related to each other. So describe two different ways you can reduce the cost for each person by a half. One way is you reduce the number of weeks by a half, or you double the amount of people. So just kind of thinking about this relationship as one thing affects the other. That's the basic idea of what we're going to talk about today and variation. Definition of a direct variation is it's a relationship expressed as, I would say, y equals kx, and one thing, k can't be zero. So k can't be zero, otherwise, there would only be a constant there. And what that k is called is a constant of variation. And the way we read the y equals kx is y varies directly with x. So y varies directly with x. That's going to come in handy as we're solving a bunch of problems. Take a look at another one. So that's direct variation. Inverse variation, think about this problem. Group of students painting a house. One student can paint an entire house in 48 hours. However, the more students that work on the house, the fewer hours each student has to work. So if S is the number of students and H is the number of hours, there's two equations we can almost think of. First one is the number of hours would have to be the 48 hours divided by the number of students. Another way we could think of that is we can just multiply the hours times the students in order to get 48. Doubling the number of students cuts the time in half. So it's like as one variable increases, the other variable decreases. They have that inverse relationship. So the way we would say that is, in this case, H varies inversely with S. So H equals 48 divided by S. H varies inversely with S. There's a third one. So the definition of it would be y equals k over x, And again, k cannot equal 0. K is still the constant of variation. And like we had said on the example before this, y varies inversely with x. So you're going to see different problems where they might say something varies directly. You're using the equation above. They might say it varies inversely. You're using this y equals k over x. Or there's the third one of joint variation. Joint variation is another type of direct variation. So they vary directly as the product of two or more other quantities. So instead of just having two things, now we're looking at something like z equals kxy. So k times x times y. K still can't be 0. And the way we would read that is z varies jointly with both x and y. So there's those three types of problems, kind of the 4 steps to solving these. You're going to first write an equation that describes the variation, and that's all going to be information that they give you. So direct variation, y equals kx. Inverse variation, y equals k over x. Or joint variation, z equals kxy. And those variables are the y, x, and z. Those can be any type of variables depending on what they're giving to you in the problem. You then find the constant of variation. You use that constant of variation to write the whole function. And then you evaluate for whatever they're trying to find. So let's do 2 example problems, and then there's a couple that you'll do on your own. So the first thing, y varies directly with x. So they're telling you it varies directly. They're saying y varies directly with x. So we're thinking y equals kx. They said if y is 9 and x is 2, find the following. So then there's always going to be 2 parts. So y is 9. They're telling you y is 9. And then x is 2. So it's k times 2. So if we're trying to find k, we have to divide by 2. So we're getting 9/2. And that's fine that we have a fraction. So the equation that relates x and y, we go back to this idea of y equals kx. So our answer would be y equals 9/2 x. So it's like you use the 2 numbers they gave you, find the k, and then use that k, the constant of variation, just to come up with the equation. And then part 2 is always telling you, okay, now find whatever variable when this is equal to this. So now they're saying x equals -4. So we know y equals 9/2 x, but they're telling us it's equal to -4. So if we do 9/2 times -4, we're going to get -18. So y equals -18. Those are the 2 parts. There's always going to be the first part where you're trying to find k in order to use or make up the equation, and then use that equation to solve for whatever they're saying in part B. Let's take a look at the next one. M varies inversely as the cube of n. So cube of n, we're thinking n cubed. So m varies inversely, and inversely was k over cube of n. So n cubed. They're going to give us m equals 10, and they're telling n is 4. So we do 4 times 4 times 4. And go ahead and multiply both sides by 64. So we're getting m is equal, or k is equal to 640. So our general equation is going to be m equals 640 divided by n cubed. Part B, now find m when n is 2. So m equals 640 divided by 2 cubed. 640 divided by 8 is going to give you 80. Take a look at the next one. Z varies jointly with x and y. So jointly looks like this. Z equals k times x times y. They tell us z is 8, x is 4, and then y is 10. So 8 equals 40k, divide by 40, and you're getting 1/5. So the equation would be z equals 1/5 xy. Always use that equation for part B, and it says, so actually that's what this is. So our equation is right there. And then find z when x is 25 and y is 4. So z equals 1/5 times 25 times 4. So 1/5 times 25 is 5. 5 times 4, you're getting z equals 20. So direct variation, inverse variation, and joint variation. Those are the 3 types of variation. Just know those equations. Have it kind of by your side as you're solving the problems. And go ahead and solve those last 2 here based on what they're doing. Hope that helps. Send me any messages if you have any